If you were to take one of the main group elements and look at their outer shells, you would begin to see some patterns, especially when you look down the columns. This area in red is what I mean when I say main group elements. We are basically excluding the lanthanides and actinides and the transition metals. Every element in a group, which is also called a family or column, has the same number of valence electrons in it. That means the same number of electrons in its outer shell. Just to review, valence electrons are the electrons in the highest occupied shell of an element's atom. So we're talking about the outer shell here. Core electrons are the electrons in the inner shells. Why do we care about valence electrons? Well, valence electrons are the electrons that participate in bonding. The number of valence electrons in an atom determines what other atoms it will bond with, what type of bond the atom will form, and how many atoms can bond with it in a compound. To find the number of valence electrons for the main group elements, use the periodic table to help you. We notice that every atom in the first group has one valence electron. Every atom in the second group has two. Now, if we move all the way over to the right past the transition metals, we will see that every atom in the boron group has 3 valence electrons. Every atom in the carbon group has 4. Every atom in the nitrogen group has 5. In the oxygen group has 6. The halogens have 7, and the noble gases have 8, except for helium, which only has 2, because its outer shell can only hold 2 valence electrons. The pattern's pretty simple. Here's another way to look at it. Here's a table summarizing the number of valence electrons, but the easiest way is to just remember how to do it by looking at the periodic table. Okay, well, what about transition elements and the lanthanides and actinides? For these elements, determining the valence electrons is not so straightforward, and for high school chemistry, we're mostly concerned about the valence electrons of the main group elements. Now let's talk about Lewis dot symbols. We can represent an atom's valence electrons by using Lewis dot symbols, and these consist of the symbol for the element surrounded by dots. Each dot represents an electron, and the Lewis dot diagram represents the number of valence electrons that a particular element has. In order to make a Lewis dot diagram, do this. First, determine the total number of valence electrons on the atom. Use the periodic table to help you, and this is going to be the number of dots you use. Then, write down the symbol for the element. Arrange the dots around the element. There's no right order, and there are many ways to do this. Some people like to make sure you put dots on opposite sides of the symbol as you place them, and so each of the 4 sides should have an electron on it before you begin doubling up. But as I said, there's a lot of variation depending on the atom. Let's do an example, nitrogen. From the periodic table, we see that nitrogen is in group 15 and has 5 valence electrons on it. So we will place 5 dots around our symbol like this. Although some people prefer to place dots in a certain order, others don't. So if you look in different chemistry textbooks and on different websites, you may see any of these and perhaps others. In summary, valence electrons are the electrons in the outermost shell or energy level. When you're looking at the main group elements, every element in a given group or family has the same number of valence electrons. You can use the periodic table to help you determine how many valence electrons there are for any given element. We can use Lewis dot symbols to represent an atom's valence electrons.